Yuck. Why does my fish got metal in it?
Oh, I know this one! I did a project on it in first grade!
First grade?
Yeah, my elementary school was a little intense. Are you ready for your presentation, Emily? Yeah. Acid mind drainage.
Yikes. Ugh, yeah, it was terrible. What does mining have to do with my fish anyway?
Well, there's this thing called acid mine drainage. It occurs when Wait! This could be my second chance!
What?
I could finally give my acid mining presentation. Come here.
What?
Yeah! Right. Now, where were we? Acid mine drainage? Right. Acid mine drainage, or AMD for short. It's one of the main ways that the mining industry affects the environment. It occurs when sulfide-rich rocks mix with air and water and produce sulfuric acid, which then drains into larger bodies of water, like rivers. So why does mining cause this so much? Most valuable ores that are mined for often contain a lot of sulfides. During mining, sulfide-rich minerals are disturbed and exposed to air when they otherwise wouldn't be. In addition, to purify these ores and to sort the elements in them, they must first go through a grinding process, which leaves even more sulfides exposed to air. You keep saying sulfides are exposed to water and air, but what does this reaction actually look like? Well, the first thing that needs to be understood is that the process that produces AMD is an oxidation process. This just means two or more substances interact and one or more electrons is lost. It's also not just one reaction, but rather a chain of reactions. We start off with the oxidation of pyrite by oxygen. Pyrite is commonly found in mines. So we take pyrite, oxygen, and water and produce ferrous iron and sulfuric acid. Now I know what you're thinking. What's ferrous iron? That just means it has a 2+ charge. On the other hand, ferric iron has a 3+ charge. In our next reaction, we have the conversion of ferrous iron to ferric iron. We take ferrous iron, oxygen, and hydrogen ions and produce ferric iron and water. Now, there's certain bacteria that can speed this up, but it's also pH dependent. It occurs at slower rates at lower pHs, such as 2 to 3, and at faster rates at pHs nearing 5. Next, we have the hydrolysis of ferric iron. That hydrolysis just means the splitting of the water molecule. So we take ferric iron and water and produce iron 3 hydroxide and more hydrogen ions. Now, iron 3 hydroxide is commonly precipitated out into rivers from AMD, but more on this later. Lastly, we have the oxidation of pyrite, but this time with ferric iron as the oxidizing agent, meaning what does the oxidation? So we take pyrite, ferric iron, and water and produce ferrous iron and sulfuric acid. Wow! Yeah, I know it's a lot. So here is a summary reaction. For every 4 of pyrite, 15 oxygen molecules, and 14 water molecules, we produce 4 iron 3 hydroxides and 8 sulfuric acids. So, bigger picture, where is AMD created in the mining process? Well, first we need to understand more about how the mining process works. There are 2 main types of mines, surface and subsurface. Surface mines are what they use when the ore is closer to the surface, so they just take off the top layer of soil. Subsurface mines are what they use when the ore is deeper, and so they tunnel down to it. Both of these produce tailings. Tailings are the waste products from mines, which they put into a big pit. All of these can produce AMD. Surface mines, if not properly reclaimed by the environment, can produce AMD. There can be acid in the water that flows out of subsurface mines, and tailings have high potential for producing AMD because they are so rich in sulfur. This may be a stupid question, but why is the acid bad for the environment? To answer that, let's look at an example river. We start out with a normal river, and the animal and plant life is happy. Then, as acid comes in through groundwater, the pH decreases, which can be toxic to some animal and plant life. In addition, lower pH means that heavy metals can be dissolved. Let's imagine we're doing a demo.
We start with 20 milliliters of 2 molar sulfuric acid. Sulfuric acid is the same acid produced by AMD. We then heat it up in a warm water bath to speed up the reaction. Then we add 2 grams of copper 2 oxide, one of the common heavy metals dissolved by AMD. As we wait for the remaining copper to settle, we will see that the solution has turned blue. This is an indication that an acid-base reaction has taken place, in which water and a soluble salt, copper 2 sulfate, is formed, then dissolved, turning the solution blue.
Yeah, all these heavy metals can be bad for the animal and plant life. They can even accumulate in animals, like your fish, and eventually end up in humans. Another problem is that as more water is added downstream, the pH increases back towards basic conditions. As this happens, the heavy metals can precipitate or fall out of solution and deposit on the riverbed floor. Again, bad for animals and plants. This sounds bad. Is there anything you can do to treat it? While there are a variety of ways to treat areas affected by AMD, they all have their costs, and prevention remains the most effective. Now, there have been great strides in policy to decrease the amount of pollution produced by mines, but we are still feeling the effect of old mines and illegal mines, which didn't and don't follow these policies. There remains work to be done. That was my presentation for today. Thank you for listening. Oh my gosh, I did it!